Well, it's one of our favorite days of the week. Meteorologist Jacob Morse is here for another edition of the Morse Code of Weather. And of course, the radar series continues. Always a good topic.
I keep thinking I know everything about a weather radar, and then you tell me something new.
Right.
There's so much more to go into. This is part 3, and there's so many complicated parts that go into the inside of the radar. So we're going to go back inside the radar and take a closer look at some of those mechanical parts that make the whole thing work, that make our radar successful. So first week we talked about how the radar rotates around 360 degrees. Last week we talked about the tilt, how it goes up in elevation angles. But there's a special housing in the center of the radar that controls that rotation. And when you think about it, you have to get information and signals up to the rotating part of the radar without twisting any wires. So we'll take a closer look at that. And what happens is, in this housing is a slip ring assembly. That's where the motor is that rotates the radar, as well as a box where the signals are transferred up to the spinning part of the radar through metal contact. Metallic layers are stacked up on top of each other, with each tidbit of information that needs to go up to that spinning part of the radar transferred through those metallic discs. So now, farther up on the radar, you have those motors that move the radar up and down, what we call the elevation motors. And those are controlled and get to all of our different elevation angles. Back down at the ground, we have our backup generator that allows for the radar to operate just in case there's any power outages, and that's powered by diesel. Fortunately, that has not had to been used within the past year or so. Now also, there's technicians that the National Weather Service employs, and those technicians service the weather radar in case anything goes wrong, and they're on call 24/7. Chauncey Schultz talks more about the National Weather Service technicians.
At least once a month, they go out and do maintenance checks, things like changing the oil and things like this. It's a piece of machinery, just like your car. So we have highly trained technicians, skilled technicians, that provide at least monthly maintenance to the radar, more often as needed. If something happens to break, they make an immediate fix to it. Since the radar was originally installed in 1994, we've only taken the golf ball or the soccer ball off one time. That was actually about 1.5 years ago. And the reason that we did that is part of what we call the Service Life Extension Program. So the radar itself has been installed for going on 30 years now, but we've improved the parts in it. We continue to improve and extend the life cycle of the radar to provide life-saving information. Thankfully, our radar has never been damaged, but other radar sites certainly have been. Most recently, the Rapid City, South Dakota radar last summer was pummeled with really large hail and strong winds. And just like anything on your house that might be made out of fiberglass, it was damaged. And so the repair process for that takes time. In extreme cases, with hurricanes, for example, there have been some instances when the radars have been totally destroyed. In that case, to completely rebuild a radar, it takes a long time, many, many months to rebuild a radar. Thankfully, that's only happened a very small number of times in history. There is actually a repository of spare parts, if you will, that to help rebuild radars if necessary, but it takes time and process to completely rebuild one from scratch.
So fortunately, our weather radars in North Dakota haven't been damaged like those near the Gulf Coast or even down south in South Dakota with hail. But you need those technicians, just like with the television operation. We rely on technicians to help us out in case anything goes wrong with weather service radars. Because it's a complicated machine, you need people to service it.
Yeah, it looks complicated.
It is complicated, but there's so much that goes into it that we don't even know, right? We just want to get the radar on television and as an end user, but all of the hardware that goes into the software that gives us all these products, Doppler radar and things like that's fascinating.
And the two most important things that the radar does is obviously spin around 360 degrees, but we also need it to go up to all those different elevation angles like we talked about last week.
We might be doing a volume scan on thunderstorms here in the next few hours.
Oh,
Keep you up to
okay.
date on that.
Okay.
So thanks a lot, Jacob.
Sounds good.
You're welcome.
Thanks, Jacob.
Yeah.